So similar to the previous video, let me give you some more examples. So given these here, remember you can always derive these. So when given this, we should have. If you've been watching other videos up until now, you should be able to get from here to here, or given this here, you should be able to get from here to here. Well, given these, we can approximate something complicated. Let's say this thing here. Let's try and approximate this complicated thing here. So rewrite this thing here as this. So rewrite this thing here as the bubble here to the power of an eighth. Okay, so rewrite this as this. Now looking at this form here, you've got one thing here to the power of an eighth. So we should be using this one here. Okay, so hang on. Remember, we are going to use this here. So when you're here, visualize it as this. Visualize it as this thing here. You've got one thing to the power of another thing here. So looking at this here. Hang on. Looking at this here. Remember, whenever you have, well, you've got x here, you've got r here. So the approximation would be r. Simply just get r times x here. So remember, we are using this here. Okay, so looking at this, when you get to this stage, imagine it as one bubble here, and then you've got another bubble here. So when you approximate it, it's just simply this times this. Okay, well, anyway, when you're here, in your mind, visualize it as this. So it's just simply getting this and multiplying it with this. Okay, so get this, multiply with this, it will then give you this. So this here, remember that this thing here is, at the moment, it is precisely equal to this. So you've got to use the equal sign here. But then the minute you jump to 1 plus rx here, the minute you do that, you're approximating it. So you've got to use this symbol here, approximate. Okay, so anyway, this will approximate to this. Okay, and then you tie it up, and the overall answer would be this here. If you get terms like, if you happen to get more terms like I don't know, 7 over 8 to the power of 5 here, then here you would discard this because you've already got this. So here you would discard this, but luckily we haven't got any other terms here, so we just leave it as this. Even though this is not a linear approximation, even though it's not a straight line, it is still our approximation here. Okay, if you have some other thing and then x to the power of, let's say, 11 here, then this block here would be tiny in comparison to this block here, so you would discard this. Okay, but at the moment there's no other x around, there's no other x to the power of whatever around, so keep it as this. Okay, now get yourself a graph plotter. So the red line here represents our original, the blue line here represents our approximation. So it's not a straight line. So looking at this, our approximation here is not a straight line, it is a cubic. So but the thing is, it is near x equals 0. It is a really good approximation, because look, around this region here is a really good approximation, around this region here. So, well, the blue line represents our approximation. Okay. Now let me give you another example. Let's say you want to evaluate this thing here, near x equals 0. So rewrite this thing as this thing here. So again, similar to the previous one, you use this one here. Okay. So when you get to this stage here, visualize it as one. Visualize it as one bubble here times one bubble here, this thing here to the power of this bubble here. So when you get to this stage here, in your mind, visualize it like this, and then when you start to take the approximation, it's just simply this thing multiplying with this thing here. That will then give you this, and then get yourself a graph plotter, plot the two graphs, it will give you this. So when x is near 0, you can see that is a really good approximation here. Okay. Around here is a really good approximation. Okay.